Hey everybody, this is Mr. Munson. We're in Unit 4, Triangle Inequalities and Triangle Angle Relationships. And so in this concept video number 2, we're going to look at the triangle sum theorem and the triangle exterior angle theorem. Let's get started. Okay, the first thing I want to do is make sure that you've done a summary for the video before. So look at your sheet, your notes here, and just make sure that you have a summary before. A summary is a really good way for you to have a quick reference. Your video log is getting fuller and fuller every time that we have a video, and so for you to go back and find something, it might be easier for you to quickly read a summary to see what it was covered in that concept video before you look in page by page. Some people even put tabs on those pages where the summary at. Some people create an index in the front of it saying what's on each page. It's up to you. Okay? But in any case, let's go ahead and talk about the triangle sum theorem. The triangle sum theorem basically says this. If I have a triangle like I do at the top here, if I was to take each angle and just kind of tear it apart, tear it off of the main triangle there, if I was to do that for all three angles, and then take them and rotate them, they would all line up down here like this one, right? So if you take a look, I've done this with all the other angles here, and so basically what this ends up saying is this: that if I take angle 3, which is found up here, right? Here's angle 3 right here. If I take that piece and tear it off, and then I take angle 2 and I put it right next door to it. Here's angle 2, right? And then I take angle 1, which is right next door to it, right? And I take all those pieces of paper and line up their angles. They're going to form a set of supplementary angles. They're going to add up to 180 degrees, right? Here's the angle that they form, right? So I'm not going to say that they're a linear pair because that implies two angles, linear pair. Pair is two things, right? But they are supplementary. Let's write the. All right, triangle sum theorem says this: the angles of a triangle are supplementary. They add up to 180 degrees, right? Their sum is equal to 180. Okay, so that allows us to approach a problem like this one over here by realizing the triangle's angles are supplementary. So if you don't mind, I'm going to call this one x, and I'm just going to simply write an equation for this. Now, some people would take 47 and 52 and just add them together and subtract it from 180. But what I want you to do is get used to writing equations, because when it gets hard, you won't be able to do what you just did, right? You'll be stuck. So if we start with the simple ones, writing equations, then when it gets hard, we know how to do it. So triangle sum theorem says that they're supplementary. That means that their sum is equal to 180 degrees. So I just turned the words, the sum is equal to 180 degrees. I just turned it into symbols now. Sum being addition. It's that simple. All right, so what I want you to do now is put me on pause and do this one. Write an equation for that problem and come back and check your work. Don't worry about solving it, just write the equation. All right, so hopefully you wrote something that looked like that. Now, how you put the pieces together in different order, since it's adding, it doesn't matter which one you're putting in first. I happen to put 17x plus 4 there. Maybe you started off with the 45. Maybe you started off with the 26x plus 2. But for sure, everything, the three pieces are added together to equal that 180 degrees. All right, now this one is a triangle sum theorem problem, but there's a couple of strategies, a couple of extra things we're going to have to do, right? So first of all, let's just call that question mark an x, right? So if I was to use the triangle sum theorem, I would take x plus the 102 plus the, I have a problem. I'm missing that angle as well. So I'm going to have to back up for a second and think through some strategy. Now, what I want to encourage you to do is, if you know exactly what I'm going to do, put me on pause instead of listening to me. Put me on pause and do this problem on your own. And just solidify the understanding how to do this, because you're brilliant enough to do it. Otherwise, I'm going to go ahead and walk through it. Okay, so this is how I would do it. I would look to see, okay, I need to find that x. To do that, I'm going to need to know what this angle is. To find that angle, it would be helpful to know what this angle is. To find that angle, I'm going to use the triangle sum theorem. I have both those angles up there, so I can do that. So let's call this one y, because that's an unknown as well. So I'm going to go and find y. Let me encourage you to use notation like this on your tests so that the reader, me, coming in later can quickly and easily find your reasoning. That way you don't lose points because I say, hey, there's no work. Okay, so let's write an equation. 35 plus 95 plus that y should equal 180 degrees. That's the triangle sum theorem. That's my reasoning for that. Okay, let's solve for y. I got y equals 50, so I'm just going to put 50 there. Now I'm going to also put 50 here. Can you think of the reason, the theorem, the postulate, the property that allows me to say, hey, since y is 50, the angle on the other side is 50? Well, that's the vertical angles theorem, right? Okay, so now I'm looking for x. So let's see, I have 50 for that one angle plus the 102 plus the x equals 180 degrees. Again, triangle sum theorem. Let me go ahead and put the vertical angle theorem here. Vertical angle theorem. Okay, that's why I can move that over there. And now I'm just going to solve for x. And if I did my work right, I got x equals 28. For those people who put me on pause and did this problem on your own, give yourself a big, huge round of applause. That's awesome. All right, that's about all that I want to talk about that. Okay, so let's now talk about the exterior angle theorem. The exterior angle theorem is a relationship that an exterior angle of a triangle has with some of the remotes that are inside of it, okay? So the exterior angle theorem basically says this. If I have interior angles, let's call this one R1, R2, and R3, the exterior angle is created by extending one of the sides and one of the sides. That makes that an exterior angle. And that's not the only exterior angle. I'll show you in just a minute. There's multiple exterior angles. But there's this relationship that exterior angle has with two of the angles on the inside. Now the reason I used R's is because it references the word remote. So basically this is an exterior angle theorem. So an exterior angle is equal to its two remote interior angles. For this exterior angle, R3 is not remote. It's actually right next door. It's already got a relationship with that one. It's a linear pair. So the relationship that's interesting here is that R1 and R2 are angles that are related to it. And the reason I'm calling them R is because they're remotes. Now let's take a look at a drawing down here real quick. Let me just make it a little bit bigger so you can see it. And what this illustrates is that each corner, each vertex of the triangle has a pair of remote angles or a pair of exterior angles that go with it. And then there's this one other angle that gets formed down there at the vertex that's not an exterior, but it's commonly mistaken, okay? So let's just make sure we remind ourselves what an exterior angle is. An exterior angle is created by taking one of the sides of the triangle and extending one of the angles or one of the sides, and that creates an exterior angle. Now, if you take a look down at angle number 2, here's a side of the triangle, and here's an extension from this side, right? And that forms that angle. So number 2 is also an exterior angle. Well, where it says no, that's not an exterior angle. That's actually made up, that angle there is made up by extending two sides, if you look at it, right? So anytime you extend two sides, you do not get an exterior angle. It is definitely outside the triangle, but it's not the one of interest. Matter of fact, that angle has a relationship with an inside angle already. This one, right? Each of those angles I just showed you that were not exterior are vertical to something on the inside. It's not related to any of the remotes. Okay, so you'll need to know that the drawings can be turned and twisted, and you'll have to figure out which one is what. Okay? All right. So let's take a look and use the exterior angle theorem to write an equation for this one. Let's call this one example 3. And I'm just going to put an x here on this problem. So quickly enough, the exterior angle there is equal to 37 plus 55, right? And I could just simply solve that and get it to be, what, 92. Okay, I'll put my degree mark on it. All right, now it's your turn, right? Go ahead and see if you can do an equation for this and solve for x. All right, welcome back. I got x equals 12, and I hope you did too. Take a look at my math if you didn't and see what happened. I suspect if you made a mistake, it was probably right here with this -8. When I combined it with that, I get 10. 18 plus a -8 gives me a 10. Now, if you're having problems problems solving your equations, you need to know about it. And you need to reach out to me and show me that equation. Say, Mr. Munson, you have any strategies that can help me stop making these mistakes? Because I want to get all the points. I don't want to keep on losing points, just making simple addition and algebra mistakes. I want to get all my points. And when you do that, I'll be more than welcome to help you. You just got to ask. All right, that's it. Go ahead and write yourself a summary. Go ahead and do these problems. Submit them. Play out the video until it fully ends, and it will automatically submit your answers for you. All right, take care, everybody.